Chapter 7, Section 6 is about dilations and symmetry. By the end of this lesson, you should be able to apply similarity properties in the coordinate plane and use coordinate proof to prove that figures are similar. So the word dilation is just a transformation that changes the size of a figure but not its shape. So when you grab the little corner of a picture in Microsoft Word and make it bigger, you're dilating something. The pre-image and the image are always similar. So the pre-image is what you start with, and the image is what you get. The scale factor describes how much the figure is enlarged or reduced. And if your scale factor is greater than 1, that means it's enlarged. Like a scale factor of 2 means that it got twice as big. And if it's less than 1, that means it was reduced. Like a scale factor of 1/2 means that it shrunk. So for dilation with a scale factor of k, you can find the image of a point by multiplying each coordinate by k. So all we're going to do is take the coordinates, the x and the y, and multiply them by whatever our scale factor is. So here's a nice easy example. Draw the border of the photo after a dilation with a scale factor of 5/2. So 5/2 is a number bigger than 1. I should expect to get something bigger. So you take a look at each point. Point A is at 0, 0. So what I'm going to do is multiply both the x and the y by 5/2. And because it's 0, 0, we get 0, 0. Point B is at 0, 1, 2, 3, 4. So if I multiply 0 by by 5/2, I get 0. And 4 times 5/2, I get 20/2, or just 10. And then C is over at 1, 2, 3, up 4. So if I multiply this by 5/2, I get 15/2, or 7.5. And then 4 times 5/2 we know is 10. And then finally D is at 1, 2, 3, 0. And if you multiply that by 5/2, you get 7.5, 0. So this tells us where the new coordinate should be. A prime is still at 0, 0. B prime, I would have to go up to 10 here. C prime, I would go over 7.5 and up 10. So this is B prime, C prime. And then D, I would go over 7.5. And then we would draw the border of this picture. But basically 5/2 is 2.5, so this got 2.5 times bigger. So here's another example where I tell you these two triangles are similar, and we need to find the coordinates of U over here, and then the scale factor. So just because this is in the coordinate plane doesn't mean that we can't approach this like all of our other problems. We can use the coordinate plane to find distance. And because both of these are on the x and y axis, it makes it really easy to find the distance. -9, 0 means that this distance right here is 9. And if this is at -12, 0, it means that this bigger distance here is 12. And the same thing up here. This distance is 16, and then we don't know this distance. So if this is confusing, you can redraw these pictures with T, O, U, and then this one's just a little bigger. Let's try that again. This with S and R here. So we know that this distance is 9, and this whole distance is 12, and then we know this whole distance is 16, and we're trying to find this one. So just like we did before, we can set up a proportion. I know 12 over 9 has to be related to 16 over x. And if we find our cross products, we get that x has to be 12. So this distance here is 12. And then the next thing it wanted us to find was the scale factor. So what we're asking ourselves is, what could I do to the point 0.16 to get the point 0.12? And then we can double check that because we want to do the same thing to the point -12, 0 and end up with -9, 0. So what we're going to do is figure out what we need to multiply by. So 0 times k and 16 times k have got to give us this. So the 0 part's not going to help at all. But I know 16 times some number has got to give us 12. So nice and easy, quick to solve. We get that k is 12 over 16, but we can write that as 0.75, or you could write it as 3/4 as your scale factor. And then we can check that down here. If you take -12 and multiply it by 3/4, you end up with the -9, which is what we have in the other point. So now this is where that coordinate proof part comes in. I give you some points, E, F, G, H, and J, and we need to prove that EHJ, so the big triangle, is similar to EFG, the little triangle. So forget about coordinates for a second. The only three ways that we can prove similarity is angle, angle, side, and side, side. Now because they share one angle, this angle here, we're not going to use side, side. So we have these two options to choose from. Angle, angle requires two angles, and we only know one, so we can't use that. So we have to prove that two sides are congruent, and we already know that angle E is congruent to angle E. So our job is to prove that FE over EH is proportional to EG over EJ. Now in order to do this, we need their distances. So this is where the coordinates are going to come into play. We're going to find the distances between this using the distance formula and then make sure that they are proportional. So we're going to kind of cheat with the distance formula. Instead of breaking out the whole distance formula, use Pythagorean theorem. So to go from F to E, we're going to go 1, 2, 3, 4 over 1. So FE or EF is the square root of 4 squared plus 1 squared, which is 16 plus 1, or the square root of 17. And then we can do the same thing to find EH. So again, we can kind of cheat here. Use Pythagorean theorem. We're going to go down 1, 2, 3, 4, 5, 6, 7, 8, and over 2. So that means the distance is 8 squared plus 2 squared. And we got to take the square root. So 64 plus 4, or square root of 68. And then we got to do the same thing for the other two sides. So EG, down 1, 2, 3, 4, over 1, 2, 3, 4. So this is 16 plus 16, or square root of 32. And then finally the last one, lots of counting here, but JE is down 1, 2, 3, 4, 5, 6, 7, 8, plus 1, 2, 3, 4, 5, 6, 7, 8. So you end up with 64 plus 64, or the square root of 128. Now remember, we're comparing these to see if the proportions are equal. So we can kind of plug it back into that proportions problem that we have up here. And I want to know if the square root of 17 over the square root of 68 is the same thing as the square root of 32 over the square root of 128. And for this one, what we can do is we can cross multiply and see if we end up with the same thing. So remember, when you multiply stuff that are inside square roots, you can just multiply the numbers together inside of the square root. So this one here, 17 times 128, gives me the square root of 2,167, or 76. And I want to know if that's equal to 68 times the 32. And we end up with exactly the same thing. So because of that, we know that these two sides are proportional to each other. So because of that these two things are proportional, we can prove that EHJ is similar to EFG by side angle side. So one more problem with the proofs. Graph the image of ABC after a dilation with a scale factor of 2/3 and then verify that they are similar. So remember, just like before, we're going to take each of our points, A, B, and C, and we are going to multiply them by the scale factor. So the very first one, A, if I do 0 times 2/3, I get 0, and 3 times 2/3, I get 2. This is A prime. 3 times 2/3 is 2, and 6 times 2/3 is 4. And then 6 times 2/3 is 4 again, and 0. So then all we have to do is plot these. 0, 2, this is my new A. 2, 4, this is my new B. And 4, 0, that's my new C. So here is my image, the green triangle here. And if you look, it got a little smaller. It also moved closer to 0, and that happens if it doesn't share a common point of 0, 0. So now we need to verify that these two things are similar. So remember, there's 3 ways that we can do this. Angle, angle, side, and side, side, side. Because these don't share any common angles, we can't use angle, angle, or side, angle, side. We must use side, side, side. So you need to prove that the proportions are the same for all 3 sides. I'm going to leave this one up to you, and then we can go over it in class tomorrow. So just like we did with this one, prove that all 3 of these sides are the same proportion. So you'll have to use either the distance formula, or you can kind of cheat and use Pythagorean theorem. So you should be able to apply the similar properties in the coordinate plane, so using the scale factor, and then use coordinate proof to prove that things are similar, and that's what I'm going to leave you to do with the side, side, side. Make sure you write down any questions you have, and we can go over them in class tomorrow. Have a good night.